Hi, in this class we are going to learn a topic known as practical geometry. Now, practical geometry deals with construction of various polygons. In standard 7 we have learned how to construct a triangle and now we will learn how to construct a quadrilateral. Well, let us first do a small recap of what a triangle is and what a quadrilateral is. Well, we will first see what a triangle is. So here, as you can see, we have a triangle ABC, and this is called a triangle because the prefix tri that belongs to the word triangle says that this polygon here has three angles. The three angles are angle A, angle B and angle C. So this polygon is a triangle because it has three vertices A, B and C and three sides AB, BC and CA. So when we are given a triangle, we can find 6 pieces of information from that triangle. We can find the measure of angle A, angle B and angle C, or we can find the length of side AB, side BC and side CA. So if we are given the figure or the diagram of a triangle, we can measure these 6 parameters about the triangle. We can measure the 3 angles or we can measure the 3 sides. Well, let us now come to a quadrilateral. We know what a quadrilateral is. Well, it is a polygon that has 4 sides. And so instead of 3 sides as we had in a triangle, we have now 4 sides to this quadrilateral. Let us now call the vertices as P, Q, R and S. And so if these are the 4 vertices of this quadrilateral, I can now say that given this quadrilateral, we can write 10 pieces of information about this quadrilateral. So let's get started. Well, I will first denote it as quadrilateral. And here the prefix is quad, and this word quad means 4. So quadrilateral is nothing but a 4-sided polygon, and again it also has 4 vertices and 4 angles. So if we are given a quadrilateral, we can find the following pieces of information from this quadrilateral. In particular, we can find the measures of angle P, we can find measure of angle Q, angle R and angle S as well. So we now have 4 pieces of information that we can find about this quadrilateral. Likewise, we can also find the measures of the sides. So we can find the measure of PQ, we can find the measure of QR, we can find RS and likewise we can also find SP. So we now have 8 pieces of information about this quadrilateral. Well, I said that in a quadrilateral we can get 10 pieces of information if a quadrilateral is drawn and presented to us. So what are the remaining 2 parts? The remaining data is the length of these diagonals PR and QS. So we can now get the length of this diagonal PR, which I write it as PR here, and we can also find the length of diagonal QS, and so QS can also be measured. So now if you count the total information that a quadrilateral gives us, we get 10 different pieces of information of a diagram of a quadrilateral. So the difference between triangle and quadrilateral is that a triangle has 3 vertices, 3 sides and 3 interior angles, whereas a quadrilateral has 4 vertices, 4 sides and 4 interior angles. In addition to it, a quadrilateral also has 2 diagonals. Note that there is no concept of diagonal in a triangle. So whereas a triangle gives us 6 bits of information, a quadrilateral gives us 10 pieces of information. And now if I want to uniquely draw a triangle, I can divide this 6 by 2 and then 6 by 2 becomes 3, and so we can now remember that to draw a triangle we need 3 pieces or 3 bits of information. Can you now guess how many bits of information you need to draw a quadrilateral uniquely? Well, because a quadrilateral gives us 10 pieces of information, if we divide 10 by 2 we get the number 5, and so we can now say that a quadrilateral can be uniquely drawn if we are given 5 bits of information about this quadrilateral. So let us see how we can draw a quadrilateral using some numerical examples. Hi, in this class we are going to see how to construct a quadrilateral given enough information about that quadrilateral. So in this class we are going to learn construction of quadrilaterals. Well, in the first question here we will be given 4 sides of the quadrilateral and also 1 diagonal of the quadrilateral. So we have the length of 4 sides of a quadrilateral and we also know the length of 1 diagonal. And based on these 5 pieces of information, 4 sides plus 1 diagonal, we can draw the quadrilateral. So let's look at the question. Well, the question asks us to draw this quadrilateral JUMP. So the quadrilateral will have vertices J, U, M and P. And so we will look at the information that is given to us. First, we have been given that JU is 3.5 centimeters. So we've been given the length of side JU of this quadrilateral as 3.5 centimeters. So let's draw that. And so I fix a point J somewhere here. So my point J is, say, lying somewhere over here. Then I measure a distance of 3.5 centimeters and it brings us here. So the length of this segment JU is 3.5 centimeters, which we indicate here. Next, let's look at what else is given to us. And so now we have used JU equals 3.5 centimeters, which is indicated by a check sign here. Next, we look at the other data given, that is UM equals 4 centimeters. And we know that the point U is over here. And so because UM is 4 centimeters long, the point M will be somewhere on the arc drawn with U as the center and radius 4 centimeters. So we now have to take U as the center and draw an arc of radius 4 centimeters. So let's do that. So now we have to draw an arc with U as the center and radius equal to 4 centimeters. This is because this distance UM is 4 centimeters. So what I do? Well, I place my compass at this point and note that the distance between these two tips of the compass is 4 centimeters. So this is the distance between these 2 points is 4 centimeters, and so we take the measure 4 centimeter and place the compass at point U. So I carefully place my compass at point U and then draw an arc, and the radius of this arc is 4 centimeters. And so my point M will lie somewhere on this arc, and so we will label M in the bracket, which means the point M will lie somewhere on this arc. Now we've also used this information now. Let's look at what else is given to us. Well, we have been given that MP is equal to 5 centimeters, but we do not have the position of point M. We just know that it lies on this arc. So we will use this piece of information a little later. Let us now move to this information, Pj equals 4.5 centimeters. Now, because Pj equals 4.5 centimeters, point P will be 4.5 centimeters away from point J. But we already know what point J is, and so I will draw an arc with J as the center and radius equal to 4.5 centimeters. So let's do that. And now I want to measure a distance of 4.5 centimeters between the two tips of this compass. So I keep one tip at 0 and the other tip at 4.5, and so I have this distance between the two tips as 4.5 centimeters. And now with this radius 4.5 centimeters, I keep the fixed end at point J and I draw an arc. Well, this arc looks somewhat like this. And now I have drawn an arc with 4.5 centimeter radius and J as center. And I know that P lies somewhere on this arc. So I will write a P here, which implies that the point P lies somewhere on this arc. So we've now used this piece of information as well. Now coming to the last bit of information that we have, we know that PU is equal to 6.5 centimeters. So let's see if we can use it here. Well, we know the point U, and so to find the point P, I will draw a circle or an arc keeping my compass at this point U and taking a radius equal to 6.5 centimeters. So let's do that. So again, I have my compass and my ruler and I have to measure a distance of 6.5 centimeters. So keeping one tip at 0 and the other at 6.5, I will take the measure or the radius of this arc as 6.5 centimeters, and then I will put this fixed end at point U and draw an arc of radius 6.5 centimeters. And having drawn this arc with U as the center and radius 6.5 centimeters, I know that P is the point lying somewhere on this arc as well. So we have used this piece of information and we have found that the point P will also lie on this arc. So now we know that the point P lies on this arc as well as on this arc. In other words, the point of intersection of these two arcs will give us the exact position of point P. So P lies somewhere here. And so now I have the three vertices of the quadrilateral P, J and U. All that now remains is finding the fourth vertex M of the quadrilateral. So we will now come back to the piece of information that we haven't used yet. I note that PM is equal to 5 centimeters, and so points M and P are 5 centimeter apart. In other words, I know the position of point P and I have to find the position of point M, which is 5 centimeter away from point P. So what will I do? Well, I will do the same old trick. I will take my compass and place it at point P and then take a radius of 5 centimeter and draw an arc. So let's do that. And now I will take this compass and measure a radius of 5 centimeters. So the distance between the two tips should be 5 centimeters. And now having taken this distance between the two tips as 5 centimeters, I will place this point at point P and draw an arc. Now this arc we know has radius of 5 centimeters, and so we now know that the point M will lie somewhere on this arc. And so because point M lies on this arc, I write a M in bracket next to this arc. And now, similar in the way that we found point P, we can now locate the exact position of point M. Well, it's easy to see that because point M lies on both these arcs, the point of intersection of these two arcs will be the exact position of point M. So now I have located the four vertices J, U, M and P of the quadrilateral JUMP that we were required to draw. And now I can simply join these four vertices and get the quadrilateral. So now I can join the points P and J. Next I can join the points U and M. And likewise I can also join the points P and M. So after having drawn all the four sides of the quadrilateral, I will now try to label the quantities that are given to us in the question. So what do? Well, we notice that JU is 3.5, so this distance is 3.5 as was there earlier. Next we have UM equals 4 centimeters, so let's label that. Well, this distance UM is 4 centimeters. Next we also have MP is equal to 5 centimeters, and so MP, this length will be 5 centimeters, and we will indicate it in our diagram. Likewise, we know that PJ is 4.5 centimeters, so let us write that as well. We know that this distance PJ is 4.5 centimeters. And finally, we have PU equal to 6.5 centimeters. So we will now draw this diagonal between points P and U and label it as having the length 6.5 centimeters. So we've now drawn the quadrilateral and labeled the correct dimensions, which brings us to the end of this question. So we have seen how to construct a quadrilateral when we are given four sides of the quadrilateral and the length of one diagonal as well. Well, we can also draw a quadrilateral if some other pieces of information are given to us. So in this case, we have been given 3 sides and 2 diagonals, and we can still find the quadrilateral and construct it uniquely. So let us see how it's done. Well, we have to construct the quadrilateral GOLD. So the vertices of this quadrilateral are G, O, L and D. And we have the following dimensions of the various segments that form the vertices of the quadrilateral. Now we know that OL is 7.5 centimeters. So let us fix a point O somewhere. So point O lies somewhere over here, and a point L will be 7.5 centimeters away from point O. So let's draw the point L. So I keep my ruler at point O, and at a distance of 7.5 centimeters from this point, I will have the other point, that is point L. So I have found out the two vertices O and L of this quadrilateral, and so I can simply join them. And so I have now joined this straight line segment between points O and L, and I will label it as 7.5 centimeters as is given in the question. So now we have side OL of this quadrilateral. We have to find the remaining two vertices. So let's see how we can do that. We will indicate this piece of information as used by us. So coming to the next information, that is GL equals 6 centimeters. Now from point L, the point G is 6 centimeters away. So again I will use my compass. And so because we know that GL is 6 centimeters, we can take our compass and measure 6 centimeter distance between the two tips. And so this distance is 6 centimeter. Having taken this 6 centimeter radius, I now place the fixed end at point L, and then I draw an arc, and the radius of that arc, as we know, is 6 centimeter. And now having drawn this arc with radius 6 centimeter and center L, we can say that the point G lies somewhere on this arc. So I will label G lying somewhere on this arc. So we have now used this information as well. Coming to the next piece of data, we know that GD is 6 centimeter. But we do not have the exact position of point G, neither do we have the exact position of point D. So points G and D are completely unknown to us, and so we will skip this information for now and proceed to the next bit that we have. Here we have LD equals 5 centimeters. Well, I have my point L here, and so I can keep my compass at point L and draw an arc of radius 5 centimeters. So let's do that. So now I want to measure a radius of 5 centimeters. So I take the same scale and I put the first tip at 0 and the other tip at 5, and measuring 5 centimeters, I will now place the point of this compass at point L and then draw an arc which is 5 centimeter in radius. And now I know that my point D will lie somewhere on this arc. So I will label D here to avoid confusion. So I now use this information as well. And now we come to this last bit of information, which is the length of segment OD is 10 centimeters. Now we know that O is the point over here, and so if we want to find a point D, we know that we can take a radius 10 centimeter and keep the compass at point O and draw an arc of radius 10 centimeter. So let's do that. So again I use my compass and the scale, and I measure a radius of 10 centimeter between the two tips of this compass. And having taken the distance between these two tips as 10 centimeters, I now use this information, that is I keep my compass at point O and then draw an arc of radius 10 centimeters. So the arc will look something like this. And having drawn this arc with O as center and radius 10 centimeter, I can now say that the point D lies somewhere on this arc. So let us label D here in brackets, which tells us that the point D lies somewhere on this arc. But now we had previously seen that the point D lied on this arc as well, and so we now have point D lying off both these arcs, and so the point of intersection of these two arcs will give us the exact position of point D, and so this will be our point D. So now we have found out three vertices O, L and D, and the only vertex that now remains is the vertex G. For that we come to this piece of information that we haven't used as yet. Well, now here we are given that GD is 6 centimeter. So what do? Well, I know the point D now, and so the point G will be 6 centimeter away from D. So again I do the same old trick using my compass. So now I take this compass and I keep one tip at 0 and the other tip at 6 centimeters. And having measured this distance as 6 centimeter, what I now do is I will put the point of this compass at point D and draw an arc with radius 6 centimeter. So let us suppose the arc looks like this. And so now I know that my point G lies somewhere on this arc. So let's label this arc as G. So we now have this arc on which the point G lies, and likewise we have this arc again on which the point G lies. So we can safely say that because the point G lies on this arc as well as on this arc, it will lie on the point of intersection of the two arcs. So here I can write point G, and I have successfully located the point G here as well. So now our work is done. We only have to join the four vertices of this quadrilateral, and so we can get the final quadrilateral. So let's do that. So first we will start with this point G and connect it to point O. So we have one side of the quadrilateral, that is GO, is obtained by us. Next we look at the other sides. Now we know the vertex L and the vertex D, and so if we join them, we get the side LD of this quadrilateral. And now the only thing that remains is joining the vertices G and D, and that can be done very easily. So now we have found out the four vertices of this quadrilateral and then joined them in order to get the final quadrilateral. So now, having obtained this quadrilateral, let us denote or label the quantities that were given in the question. First, we were given that OL is 7.5, which we have already marked here. Next, we are given that GL is 6 centimeter, and we know that GL is this diagonal. So we join these 2 points as diagonal GL and label it as 6 centimeters. So this is 6 centimeter in length. Next, we come to this information where GD is 6 centimeter. So we know that this distance between point G and D is 6 centimeter, and so we label it appropriately as 6 centimeter. Now, coming to the next bit of information, we have LD equals 5 centimeter. So let's mark that as well. LD is 5 centimeter, and so we've drawn or labeled it as 5 centimeter length. Lastly, we have OD is equal to 10 centimeter, and we know that OD is this diagonal, and so we can also draw this diagonal and measure it as 10 centimeter and label it as 10 centimeter rather. So now our entire quadrilateral is ready with the sides labeled accordingly. This brings us to the end of the solution to this question.